Hi, everybody. Welcome back. Before I jump straight to the problem, I want to remind you of the free resources that I have. Number one, I have a guide named How to Evaluate Your Education in United States of America. Number two, another guide about shear moment diagram, which has a solved example and then a few examples that I have collected from various FU materials. If this sounds something that you might need, click the links below and you'll be able to download them for free. Now let's move on with our example. The flexural design strength of the reinforced concrete beam section shown is most nearly. So right from the beginning, if you have problems understanding what is flexural design strength, just go to the FE handbook, do a search, flexural design strength. There you go. So it is phi times mn. So this is what the problem is asking us to calculate. This is design flexural strength. Okay, so we must calculate phi mn. So first off, let's go ahead and calculate mn. As we have previously calculated in our problems, the mn formula is given here in the FE handbook, and we can use one of these formulas. Let's use this one because I believe we have we can calculate A and D is given. So let's write this formula down. So mn equals to AS times Fy D minus A over 2. So D is distance from extreme compression fiber to centroid of longitudinal tension reinforcement. So in our case, D is 20 inches. Now let's calculate A. A equals to, let's have a look here, ASFY 0.85 FC prime B. AS times FY over 0.85 times FC prime times B equals. Again, AS, it's the area of reinforcement, which we can easily calculate because the problem tells us we have 4 number 8 bars. So just go and look for the table where you're given the areas of reinforcement bars. And we have number 8, 0.79. We have 4 of them. So 4 times 0.79 equals 316 inches squared. So now here we add this 316 inches squared. The Fy, I forgot to write it here, Fy is given as 60 ksi and Fc prime is given as 4 ksi. So Fy here is 60, 0.85 times Fc prime 4 times B, which is 16 inches. Equals. Let's do a quick calculations on our calculator. 0.85, 4 multiply, 16 multiply. So A equals 3.49 inches. Now we can go back here and substitute and calculate Mn. 60 D is 20 inches minus 349 over 2. Let's go ahead and calculate this. I did. So we get 3,461.6, and this is keep inch. Okay, so MN, remember MN is required in foot kips, so we'll have to transform it from kip inches into kip feet. So the way to do that, obviously just divide by 12, and we get 288.5 foot kips. And now we must calculate the phi. So in order to calculate phi, we have to calculate tensile strain. So let's write the formula for the tensile strain. So tensile strain equals to 0.003 over dt minus c over c. dt minus c over c. Now, dt, let's look here, is distance from extreme compression fiber to extreme tension steel. So in our case, we're going to use dt as d. Okay, so we have 0.003 20 inches minus. And now let's see, do we have to calculate C? Where should I write this? So looking at the FE handbook, C is given as, so A equals beta 1 times C. Let's write this down. A equals beta 1 times C. And from here, C will equal A over beta 1. And it will equal to 349 over, and beta 1 is FC prime. In our case, it's 4,000 psi. So here it tells us that beta 1 equals to 0.85 if FC prime is in between this interval. So less or equal to 4,000 psi, which is our case. So in our case, beta 1 is 0.85. So 0.85. So this is how we calculate C divided. So C equals to 4.1 inches. So let's go ahead and substitute here in this equation, 4.1 over 4.1. So we'll have 24.1 minus 0.003 multiplied 4.1 divided. So we get 0.0116. Okay, so ET equals to 0.0116, which is greater than 0.005, meaning that our phi equals to 0.9. And now going back to the MN that we calculated previously, moving forward, phi MN equals to 0.9 times 288.5 equals. So we get 259.65, and this is foot kip. The closest answer is B, and this is our correct answer. That's it for today. It was not a complicated problem at all. If you have any questions about this problem, don't forget to leave it in the comment section below. If you found this video helpful, please give it a like and subscribe because this helps people like you find me. Keep up the good work on practicing the FE problems, and I will see you next week.